Hello, I'm Anna Mackay, and this video is on the chain rule, and it's the second in the differential calculus series. To talk about the chain rule, we need to discuss composite functions first, and they're made up of two simpler functions. Now for my students, make sure you're writing everything down that you see on the screen, typed and handwritten. So if our f of x function is this, and our g of x function is this, we're being asked to take the g of x function and put it inside the f of x function. So to write that, we write f of the g of x, which is x squared plus 3x. And so where we see the x in the f of x function, we put this in its place. So we're going to substitute this in where we see that x. And we end up with that function all squared. Moving on. A bit more practice. If here's our f of x function and here is our g of x, we need to take this 5 take 7x and put it inside the g of x function. So first of all, we would write g of f of x, putting in the f of x, and now putting this part, the 5 take 7x, in to where you see an x of the g function. So that becomes the square root of 5 take 7x. Sometimes you may be asked to identify what the two functions are. So the function that's on the inside often tends to be the more complicated function, or it's got a few extra parts to it, whereas the outside function tends to be simpler. So looking at this fraction here, the inside function, the g of x, would be this part here. So we would write g of x is equal to x cubed take 2x. Now there may be more than one answer for these f of and g of x functions, but I'm just going to provide one. And the second one is, if you imagine that as an x into that function, you would end up with 1 on x. Obviously you can always check this by substituting it back in. So moving on to the chain rule, here's the official definition. And that's just in a terminology where it's basically implying that there's a function in a function, and you have to account for the derivative of both of them. The official rule is, if you have a function raised to a power, as we've been practicing, you bring the power down out the front and lower the power by 1, but you just copy and paste what's in the inside there, and then you differentiate it. So let's practice that. So finding the derivative here, dy by dx. So as I said, you bring the power down out the front and then copy and paste what you see in the bracket there. So we're going to have a 3 out the front, 2x squared take x to the power of 2. And now you differentiate the original inside of the function. So thinking about that as a derivative, you bring the squared power down, and it would become 4x take 1. And brackets are essential here. You can't just be leaving this take 1 off on the end on its own. Second function, it's going to be easier if we rearrange that first to have a negative power. And now we can differentiate. So our derivative is dy by dx. Bring the power down out the front. So we have negative 2. Copy and paste the rest of the function, lower the power by 1, and differentiate the inside here, which will become 4. And you can just leave it like that. You don't need to tidy it up unless you're working with the function further. A more applied question here, find the slope of the tangent to this function at a point. So when in doubt, differentiate first. Let's rewrite that one so we can use our laws of differentiation. So we will need to write that with a negative fraction power here. Now we can differentiate. So the derivative is dy by dx. So we leave that 4 there and bring the power down out the front. So we're going to have 4 times by negative 1/2. Copy and paste the inside. Lower that power by 1. So we get negative 3 on 2, and then differentiate the inside here. So you'd get a negative 2. And because we're going on with this function, it makes sense to tidy it up a little bit. So 4 times by -2, what do we get there? We have -2 times by that -2 will give us +4. And the rest will leave like this. Now, at a point. So essentially we're going to now substitute this point in to the derivative function. So I like to write what I'm doing, sub x equals -2. So the derivative function is the slope function, so we're finding the slope of the tangent at that point. So where we see an x, we're going to sub in a -2 to get, got enough brackets, yes? To get one I have prepared on my calculator earlier, we have 0.36, let's call it. Now I'm going to show you how to check this on your graphics calculator. So my next screen says, so that when you use it in graph, you can turn the derivative on and check it in graph to see if you've got approximately the right answer. So to do that, bear with me while I switch screens here. Right, so I have an old emulator, so bear with me. We're going into graph menu 5 and typing our function, which is here. So we have 4 divided by bracket the square root, now a bracket, 1 take away 2x, close that bracket, close the original bracket to the, no, that should do us. Now enter, view window, standard view window. Now this is the extra bit, shift setup. I want to turn that derivative on, and now graph. Now to check the answer that we got, which was the 0.36, we're going to be approximately correct. Shift trace will do this for you. Gsolve doesn't put the derivative on as far as I know. Type in -2 because it was at the point -2, enter, and here you'll see dy by dx, and we have 0.3577, which should be the answer that we're after. So that's how to check it with your calculator. Just to cross check this now. So that was the end of that video. The next video in this series will be called the product rule. Thank you.